Now the third problem, which is based on the Kirchhoff's law. In that example, we have to find the voltage or a potential difference between the X and the Y terminal. Firstly, we will draw the component between the X and the Y terminal as like this. At the X terminal, the resistor of 3 ohm is connected. Then this 3 ohm resistor is connected to the voltage source 4 volt. Then this voltage source is connected to the 3 ohm resistor. Then this 3 ohm resistor is connected to the terminal Y, and we have to find the voltage difference or a potential difference between the X and the Y. Before that, we are considering the different nodes. Suppose this is the A, node A, B, C, and this is the X. Then D, E, and the F. Now we have to give the polarities according to the direction of the current. Suppose this is the 2 volt source and this is the positive terminal, and we know the current flowing from the positive terminal. So suppose the current flowing through this voltage source is I1 like this, which is in the anti-clockwise direction, and the current flowing through this 4 volt source or a battery is like this. Suppose it is I2. Then simply for finding the voltage or a potential difference between the X and the Y, we know the voltage across the 3 ohm resistor, and we have to know the voltage across the 3 ohm resistor, and we can add these 3 voltages and we can get the voltage across the XY terminal. Now for this purpose, we have to find the current through the 3 ohm resistor, then and then only we can find the voltage across the 3 ohm resistor. For that, we are applying the KCL in the first loop and the second loop. Suppose the first procedure is apply KVL in loop A, B, C, X, A. A, B, C, X, A. Before that, we have to consider the sign conventions according to the actual direction of the current. Here the actual direction of the current is like this, anti-clockwise. That means this I1 is flowing through the 3 ohm resistor like this. That means from, suppose I am considering the starting terminal is plus and the end terminal is minus. And for this resistor, it is also starting terminal is plus, end terminal is minus. This I1 current will not flow through this 4 volt source, because when it flowing through this source, circuit will not be completed. Therefore the I1 will flow only through this circuit or through this loop A, B, C, X, A. And here the sign conventions will be like this. This current which is flowing like this clockwise, in the clockwise direction, that means in this direction through the 3 ohm and through 5 ohm like this. Suppose the current flowing through like this 3 ohm from 3 ohm resistor, that means I am considering the starting terminal is plus, end terminal is minus. Here also the starting terminal is plus, end terminal is minus, because current flowing in the upward direction. Likewise, we are considering the clockwise direction. Now we are applying the KVL in the loop A, B, C, X, A. Then the equation will be, suppose in that for the 2 volt voltage source, current is flowing like this, that means negative to positive, that means it is rise in voltage, and we are considering it is positive, so simply it is 2. Then this current will be flowing like this through the 3 ohm resistor, plus to minus, that means it is fall in potential, therefore I am considering it is negative 3 into the current which is I1, and through the 2 ohm resistor it is minus 2 into I1, because current flowing from positive to negative, that is full in voltage, it is equal to 0. So therefore 5I1 is equal to 2. Therefore I1 is equal to 2 upon 5, which is equal to, that is 0.4 ampere. I1 is 0.4 ampere. I1 is equal to 2 upon 5, it is equal to 0.4 ampere. Now we are applying the KVL in the second loop. Apply KVL in loop DYFED. DYFED. Then we are starting from the 4 volt source. That means current flowing like this, negative to positive. That means is rising voltage, and we are considering it is plus 4. Then here current flowing from plus to minus, so it is falling voltage, so it is 3 into I2. I2 is the current flowing through the 3 ohm resistor. Similarly, current through the 5 ohm resistor, it is from positive to negative, therefore it is falling voltage, and we are considering it as negative 5 into I2, which is equal to 0. So therefore 8 I2 is equal to 4. Therefore I2 is equal to 0.5 ampere. Okay, now we are putting these values, or we are finding the voltage across the 3 ohm resistor and this 3 ohm resistor. Simply like this. Now we have to find voltage across 3 ohm resistor in the first loop, which is equal to 3 into the current flowing through it is I1, which is current flowing through it is I1, which is 0.4 ampere, and it is equal to 1.2 volt. And voltage across 3 ohm resistor, which is in the second loop, is equal to 3 into current flowing through it is I2, and I2 is equal to 0.5 ampere, so which is equal to 1.5 volt. Now this sign conventions we are giving in this circuit. Simply X terminal having the negative terminal, then this positive terminal is connected to the negative terminal of the battery 4 volt, so it is positive terminal. Then this positive terminal is connected to the positive terminal of the resistor, and negative to the Y terminal. That means here the X terminal is negative, and Y terminal is positive. So simply here we are finding the voltage across the X and Y terminal by considering the X is negative with respect to Y. X terminal is negative with respect to Y. So therefore voltage across X, Y, which is equal to voltage across the 3 ohm resistor, or simply I am considering the one direction for finding it. So simply I am going from X to Y, or simply minus 2 plus, therefore it is plus. So plus voltage, it is 1.2 volt, or simply 3 into current flowing through the 3 ohm resistor is I1, and I1 is having 0.4, so simply it is 0.4. And here we are also going from negative to positive, therefore it is plus 4, and here we are going plus to minus, therefore it is minus 3 into the current flowing through the 3 ohm resistor, it is I2, so simply it is 0.5, or which is equal to 1.2 plus 4 minus 1.5. Our final answer for the voltage across X and the Y terminal is 3.7 volt. This is the final answer. Simply we have to write the terminal position or a terminal polarities. Here X terminal is negative with respect to terminal Y. Thank you.